This is Jeff Badger, the Grinding Doc, and I'm continuing my series on the great research papers of Professor Stephen Malkin. In video number one, and doesn't necessarily mean it's number one is his best video, it's just I chose 10 papers and randomly gave him a number. But in the first video, I give a little more details on Malkin's backgrounds, where he went to school, where he was a professor, the type of research he did, and then some of the reasons why his research is arguably the best. And then this is the 9th one in the series, where I'm going to talk about one of his or two of his papers on grinding of brittle materials. Okay, and I'll explain why it's one of the great papers. So two of the great papers of Stephen Malkin, and this one is when he started to get into grinding of ceramic material. Now, ceramic material, glass or silicon carbide or silicon nitride or aluminum oxide or just hard brittle materials. And you can grind them. You grind them typically with a diamond wheel, occasionally with a silicon carbide wheel, but typically with a diamond wheel. And Malkin started to get into this. And he got into it when he was a professor at SUNY Buffalo. I didn't even know that. I always thought he went from MIT to University of Texas to Israel to Amherst, but it looks like he had a short stint in Buffalo also. And he did work in 1976 at the Journal of Engineering for Industry. You don't hear about them as much anymore, but during the 60s and 70s, they were probably the best source of good grinding studies. So here we have grinding of glass, surface structure, and fracture strength. And I'll go through this quickly. And Malkin, being the clever guy that he is, he didn't just say, hey man, I'm going to grind a bunch of ceramic and I'm going to give you a bunch of measurements and tell you what the values were. He said, hey, I'm going to grind a bunch of glass. We don't really have a good handle on the fundamental material removal mechanisms of what happens when the grit contacts the workpiece. So I'm going to study that. And he gave us electron microscope photos, which are better in the original than they are here, of what that surface looks like. And if you take my course, I give a bunch of pictures of what a ground surface looks like when you grind steels, ductile material, and then what a ground surface looks like when you grind a ceramic material, and they're vastly different. And in ceramics, you just sort of crack the hell out of the workpiece and then clear away the chunks of cracks. And he gives us pictures of swarf. And here we have glass. Here we have the swarf. I don't see chips there. I see hard, little small platelets and particles because the metal removal mechanisms are different. So he starts from first principles. And I keep saying, if you listen to the other videos, that's what makes Malkin's papers good, is he gives it to you from first principles. And here he is grinding with, looks like silicon carbide. Most ceramics are ground with diamond. Here he's doing silicon carbide. And then he switches over to diamond here, presumably to tell us if there's a difference. And then do we have the transition between ductile, the brittle material removal mechanisms, and stuff like that. And he's really focusing here on just hardcore mechanics of the contact between the grid and the workpiece. And then he gets into some fracture mechanics here and tests of failure, impact strength type stuff. How many are going to fail based on the stress that's applied. And then we're going to do some kind of Weibull distribution or something saying, hey, different materials are going to fail differently. And then what we've learned in grinding is if you grind more aggressively, the radial and the lateral cracks, or in particular the radial cracks, penetrate deeper and therefore give you a lower strength. So Malkin's doing his homework and asking these basic questions. And that's the first paper. The second paper he did with the same guy, and he did a bunch of tests and pulled 2 papers out of it. He probably could have pulled 5 papers out of it. And now he's getting into the different types of ceramic materials, and then how do they behave differently in grinding, and then what is the grinding energy based on the different materials. And he did this for his Ph.D. The glass softening temperature, And as we get a higher glass softening temperature, is a higher specific energy. It's more difficult to grind. And this is just straight up first principles. And then we have more of the same specific grinding energy versus the depth of cut. And this is what is unique about grinding of ceramics is you don't get the typical curve where it kind of just gradually comes down because you get less rubbing and more cutting. What you get is a very steep one, and then it stays almost constant. Not quite constant, but almost constant. And that's important. This is very good to know because we probably didn't know that before. Here we have a similar curve, glass softening temperature versus specific grinding energy, and depth of cut, specific grinding energy again. So the parameters are varying these things, etc., etc. Then he's getting into the scratch widths. This is hardcore removal mechanisms. And then he's looking at the scratches to see what's going on. So this is two of the great papers. I'll probably just kind of categorize them as one because it's the same fundamental concept is what happens when you grind ceramic material. Ceramic is a different animal than steel. I mean, a lot of this stuff's the same. How to cool, grit penetration depth, truing the wheel, sticking the wheel, clearing out resin, stuff like that. But the fundamental mechanics are different. And Malkin didn't do a bunch of tests and give us a bunch of results. He analyzed it from first principles, and that's what makes his papers better, special, unique, more based on science, is what are they from first principles. So this is Jeff Badger, the Grinding Doc, talking about the great papers of Professor Stephen Malkin.